our short lesson today, we are going to talk about two quick topics. One is detour proofs, and the second is a refresher on the midpoint formula. The reason that we are looking at this as a video is that this is something, the idea of detour proofs is something that you actually have probably instinctively come across. It's just one way to put together things that we have already learned, and we want to formalize it here as we will see it more this semester. So what is a detour proof? A detour proof is when you have to prove more than one set of triangles congruent to reach your conclusion. So with the detour proof, what you're going to see in this procedure outline below, which is there for you, I'm not going to walk all the way through it, is essentially you are going to look at what you are trying to reach your conclusion. And often we start this off with congruent triangles and identify a step that we need to prove our triangles congruent. And this is going to be a case in which we realize that the triangles we need to prove congruent, we do not have enough information to do that. And if we do not have enough information, sometimes there are other triangles that will help us get that missing information, but doesn't help us reach our conclusion. That's the detour. So it doesn't get us to the end goal, but it helps us prove the triangles we need congruent. And so as you do that, take your detour, and I've seen many people do this before already in proofs. It's natural to us if we need to figure out a way to work this through. We are just formalizing it here, and then we want to use the information in those detour triangles to help us get back to where we were starting. So let's look at an example, and you can even too, if you want to look through these steps, if it's helpful to you, it is listed out for you, but we're going to do it in practice right now. So here, this diagram only actually has one set of triangles right now. We'll talk some about that. Sometimes other diagrams, like the one shown below, have multiple sets of triangles that appear to be congruent. As we look here with our given, we are given circle O, so a triangle that is placed within this circle. We have WX is congruent to WY, and we are trying to prove that line WZ bisects XY. And as a reminder, if this bisects the segment XY, we would need to know XZ is congruent to ZY. So as we start to think through how we would logically do that, let's kind of flesh out all of our ideas here. We're going to move somewhat quickly on this. I'm going to set up this proof. And I would encourage you to think about and maybe even write down what you know to start to get there. So we have our givens. And as you look this through, I see those two triangles that appear, we don't know they're right triangles, but they look sort of like they might be. And as we look at this, we have two segments already. And I would think that a lot of you might notice reflexive property. WZ is congruent to itself. And you can add that. It's a true statement. We can add that into our proof. And so we know this here. So I have two sides right now. As you think through any other things that are possible, the only other thing that we could do is you could prove that angle X is congruent to angle Y. However, that's three pieces of information, but that order is side-side angle. And remember that side-side angle is not enough to prove our triangles congruent. We don't have the angles at the top at W congruent. We don't know these segments. We do not have enough information. This is where we get stuck. So we need to find something else. This is where a detour comes in. So this circle, they actually didn't mark the center very well for us, so let's go ahead and draw that in. Let's think about how we could use this circle. What do we often do? We draw in radii. So I'm going to switch to a different color for my detour, switch to green. And I'm going to draw in these radii, OX and OY. And now, as I look at that, I have now formed some more triangles, and we can use this information to see if that helps us get those larger triangles congruent that we initially didn't have enough information. Thinking about what we might need for our detour, maybe these angles up here, those are a part of both the biggest triangle and these upper triangles. We'll see what we can do here in just a second. So Remember that when we draw in lines, we do need to state that. So draw OX and OY, and that is because they are auxiliary lines. Or if you are remembering from Mr. J, if he did this differently, maybe you say 2 points determine a line. We can talk about this in class. And then we want to prove those radii congruent. We at least, if we're not quite sure how that helps us, hopefully that should feel familiar. So OX is congruent to OY. All radii are congruent. So now I have some more segments. And as I look at a new set of triangles, we have two formed. We could do the same process with these bottom triangles, OXZ and OYZ, that we did with the original ones. You're going to come up short. So looking at those upper triangles, I currently have two sets of congruent sides. I just need one more, and reflexive property will give that to us here. I could prove OW congruent to itself by the reflexive property, and then we have enough information to prove those triangles congruent. So that would be triangle OXW is congruent to triangle OYW, and this is by side-side-side congruence. So now what we have done is we have taken our detour. These triangles do not help me prove that WZ bisects XY directly, but it's helping us get a difference, have enough information to prove a different set of triangles congruent. So now, one of the things I will highlight is that after you have taken a detour to prove a set of triangles congruent, you will always use CPCTC to get some set of congruent corresponding parts. That's why we do it. So to end my detour, what corresponding parts are congruent? There's a couple that you could pick here, but my favorite of this is the two angles at W. So angle XWZ is congruent to angle YWZ by CPCTC. So this CPCTC will always follow in it or be one of your next steps when you do a detour proof. So now I'm going to go back to my original color. As I look at this, for my big triangle XWZ and YWZ, I have a pair of segments, I have another pair of segments, and now I have an angle. That is going to form for us side angle side congruence. And so we can go back now and prove those triangles congruent. So that would mean, I'm actually going to change this color to that maroon so it goes with now going back to my triangles that I wanted to initially prove. So that's XWZ is congruent to YWZ by side angle side congruence. And then now I can prove that XZ is congruent to ZY by CPCTC, which means we know that WZ bisects XY. Different teachers have different ways to word this. I am pretty flexible as long as we get this idea of congruent segments and bisectors. We would say if a line divides a segment into congruent segments, then it is a bisector. Okay, so now here is what I am going to do. In just a second, I'm going to switch over and show you another proof. I want you to try, at this point, even in class, I would have given you this one example and then had you do example 2 on your own. So I would encourage you now to look at example 2, to mark your information and identify a detour triangle and how you might get there. I want you to either spend some time trying to work through this on your own, or in just a second, I am going to switch over, show you the completed solution, point a couple things out, and the key will also be posted. So Now I'm going to jump over to the completed solution, and then we're going to talk about the midpoint formula. So if you want to work on it, pause the video now, work on the proof. If you're ready to just look at the proof, we're going to do that now. Okay, so this is going to look like a lot. This same thing will be posted in Schoology as a key. But as we look this through, one of the things to point out as you mark your information, my goal is to prove AG congruent to FE. I see it as being a part of these two side triangles here, or you can see it as the big triangles. Both way would work. I use the small triangles here. Our detour is going to end up being these other inner triangles with vertical angles as my third piece from the givens, and we can prove those congruent here in steps 2 through 4. Once we do that, step 4 is actually the pieces we need from CPCTC. What might have been hardest is that you need to do 2 things from these detour triangles. I use segments and then angles. And then from here, I used supplements of congruent angles to get the angles, which I actually did not mark. It would be these 2 here, congruent to each other eventually here. So look through this proof. If you still have questions, we can ask those when we get back to class. But this is the second example. I hope that you are getting this idea of a detour proof, that other congruent triangles will help us reach our goal if we can't originally get there. So now let's talk about the midpoint formula. I'm going to go ahead, just for the sake of time, go back over to our other example and copy this to our blank page and refresh your memory on the midpoint formula. So with the midpoint formula, we have 2 points. We're going to call one of our points x1, comma y1, and our other point is x2, comma y2. If I want to find the point that is directly between those 2 points, the formula, you can use this, you can figure this out often by just kind of mentally looking at it, but there is a formula, and it does work every time if we do it correctly. It is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's a point, so it has an x value and a y value. We're going to work through we're going to do 2 midpoints together, and then again, the key to the notes will have the rest of the answers. So we are tasked here to find the coordinates of the midpoints of each side of triangle ABC. So I'm going to start with segment AB. And so for my notation, I'm going to say M is my midpoint. I'm going to do this little subscript with AB. So it's the midpoint of AB. So my formula, it says I add my x values together and I divide them by 2. So that's negative. You can do this in your head too. But that's negative 4 plus 6 divided by 2. That's 3 plus 5 divided by 2. So let's see here. That gives us 2 over 2 and 8 over 2. That gives us a midpoint of 1 and 1 comma 4. So 1 comma 4. Now, the other things to look for. Your x value should be in the middle of the 2 points there. So between negative 4 and 6, the halfway point is 1. That makes sense. 3 and 5, the number in the middle of that is 4. So that is our first one. If you feel comfortable and want to pause it, try the next one. We're going to find the midpoint of segment BC together here. So if you want to pause it now, do that. Otherwise, I'm going to keep going. The midpoint of segment BC. So same thing. We're going to take our x's and add them together. Now I'm going to speed this up. So I see my 2 x values of segment BC. It's a 6 and it's another 6. So 6 plus 6 is 12. So that's 12 over 2. 5 plus negative 1 is 4. So 4 over 2. That gives us 6 comma 2. So that gives me a midpoint of 6 comma 2. Alrighty. From here, if you want to find the third midpoint, I would encourage you to do that and check your answers. If you need more practice, there is one more problem on here. AM is a median of triangle ABC. Use this information to find the coordinates of M. So putting together your knowledge of a median and now this formula, that is another example for you to do. Both of these answers for the third side in the first example and example number 2, both of these examples will have their answer in the key that is in Schoology. Now that you are finished, there is going to be a worksheet that pulls questions from section 4.1, this video, and 4.3, which we did in class. That is your next task. It shouldn't take you longer than 15 to 20 minutes. Once you have that done, submit it to Schoology and you are all done. If you have questions, make sure that you ask them in class next time that we are together.